All right, this video is to talk about how to use our guru to solve the problems in section 10.2. We're introducing confidence intervals in this section, and we are also introducing a brand new distribution, the t-distribution. So recall, in this section, we will have to make a distinguish between what standard deviation we are given or variance. Okay, we know that for all means problems, and the biggest difference between a means and a proportions problem is that we would see a standard deviation or variance given or quantitative data. And we now have to pay attention to the wording of the problem. If the wording of the problem specifies that the standard deviation is literally labeled as population standard deviation, great, that makes our job easier. We will use a Z distribution. Other wordings that could hint that it's a population standard deviation or variance is that if it includes more than one study, so over several studies, a long period of time this was calculated, that's all indicating that this is a population value. If it's just the sample data, it is usually referenced in the same sentence that they reference the sample itself. And that's a snapshot. That's, hey, I have these 5 people here today, and then I'm going to calculate a mean and a standard deviation from just this sample of 5. If we were only given that standard deviation or variance calculated from a very small sample set and it's a snapshot of today, then we do need to use the t-distribution, which is a family of curves. And it allows us to calculate more accurately probabilities and confidence intervals for data that is not as accurate as those given with a population standard deviation. All right, so without further ado, let's dive right into the practice and let's try some. So first up, we have a marketing research company desires to know the mean consumption of milk per week among males over the age of 22. A sample of 715 men that are over the age of 22 was drawn, and the mean milk consumption is 4.2. Assume the population standard deviation is known to be 1.3. They want us to construct a 90% confidence interval for the mean consumption of milk among males over the age of 22. Okay, well, let's break this down. What do we know? We know that we have a sample size N of 715. So if I'm talking about passing a central limit theorem, I either had to know the data was normally distributed, which was not mentioned in this problem anywhere, or my sample size needed to be bigger than 30 because I do recognize that the word mean popped up a bunch of times, and I've recognized I'm in the world of the means, and that is the criteria the central limit theorem requires us to pass so that the following formulas are valid. So we're good to go. Our sample size is big enough. Right after they mentioned the sample size, they talked about this mean. So that tells us this is the sample mean, X bar, for 4.2. Notice they explicitly labeled our standard deviation for us, the population one, making this sigma, not S. And that automatically tells us that we can use the standard normal curve or the Z distribution. And that's because, again, we have the more accurate standard deviation given. It was calculated from a population, not just the 715 males in the sample. We also need to know our confidence interval being 90%. Okay, so let's pop into our Rguroo so I can show you how to calculate these confidence intervals. So if we come over here, we're going to head over to Analytics, drop down the Analysis menu, and in Chapter 10, we will be choosing between the world of the means and the world of proportions. Okay, 10.2 is all about means, but you do have to decide between the Z curve and the T curve, and 10.3 will be everything proportions. So in inferences, we only need to select one population. In this particular stats course, we do not handle 2 populations. So this is what our calculator looks like. We are going to be using this calculator for both Chapter 10 and Chapter 11, so we'll get comfortable with it. If we were given a quantitative data set, we could have created a data set and made that happen, which we'll do a problem just like that. But because we don't have a data set, we actually do not need to worry about these top drop-down menus. We just got to fill in what we know. We know our sample mean was 4.2. We know that they did not give us the sample standard deviation. In fact, they explicitly labeled it the population one. So please make sure to be careful to fill out the correct box. You will not be filling out both. It's one or the other. My sample size is 715. You'll notice that in this chapter, we are not calculating the standard error ahead of time. That is only for the continuous probability calculator. Here, they ask us for the sample size because they're going to do that behind the scenes for us. We will need a variable label. In this case, it's the consumption of milk. But realistically, you could just put XYZ there or any mumbo jumbo of letters. It just needs a label. So if you don't need it to be accurately labeled on your report because you're not actually handing in the reports, you could just put anything in that box. Confidence intervals is this first tab. Tests of hypothesis is chapter 11. But in this chapter 10, we are going to change this to 90%. You should have noticed that it defaults to 95. Every time you open this calculator, it will default to 95. That is our default confidence level. If it is not given in a problem, that is what we assume the confidence level to be. And we do not need to worry about the right half of this box. In this particular course, we only need to select between a Z distribution and a T distribution. Again, how we select which one to use has everything to do with whether we were given the population standard deviation or just a sample standard deviation. Since we were given the more accurate population standard deviation, we will be using a Z distribution. And when I hit my eyeball, I am given this report. So this report tells me a couple things. It tells me the information that I entered is up here. And then down here, it tells me every little part of the formula that if we were doing this out by hand. So our standard error, which we've practiced a lot in the last chapter, is our sigma divided by the square root of the sample size, or standard deviation divided by the square root of the sample size. And notice it's already calculated for us. Our margin of error in a confidence interval is what we add and subtract to the center, the mean, to get this range, this lower and this upper limit where we can be, in this case, 90% confident our population mean falls somewhere between this range. So this margin of error is actually made up of what's called a critical value that marks the middle 90%. Confidence interval areas are always going to be middle areas centered at the middle. And it takes the critical value and it multiplies it by the standard error. So if I wanted to know what that critical value was, I could take the margin of error and divide it by the standard error to get that critical value. I'm going to show you how to use the probability calculator to find those critical values because that is going to be calculated prior to any rounding and it will always be more accurate. But to finish up this problem, let's see, they wanted 1 decimal place. So I'm going to be 4.1 as my lower limit. And my upper limit is going to be 4.3 when I round 1 decimal place. And essentially what I've just found is that I can be 90% confident that the population average consumption of milk per week for males over the age of 22 will fall somewhere between 4.1 liters and 4.3 liters. Okay. Moving on to another type of problem, let's see. This one's asking us to find a critical value, so let's practice finding critical values. So a researcher records the repair costs for just 27 randomly selected refrigerators. So right now I have a sample size of 27. That does not meet the threshold of 30. So if, as I keep reading, if it doesn't mention the population is normally distributed, then I will not be able to proceed as the central limit theorem will not have been passed. We have a sample mean. Okay, so that's X bar. I'm writing this stuff down. Sample mean of $60.52 and a standard deviation of $23.29. Now notice this time the standard deviation was not explicitly labeled sample standard deviation or population standard deviation, but it is implied to be the sample standard deviation because it is listed right after they were talking about sample stuff. So they group that stuff together. So here we can assume that this is sample standard deviation as it was listed in the same sentence right after the sample mean. We want a 90% confidence interval this time. Okay, so I think that's what it was set at the last problem. And we want to assume the population is approximately normal or normally distributed. So there we go. We've just passed our central limit theorem. Now we need to decide this critical value that they want us to find. Is it a z coming from a normally distributed curve or the standard normal curve? Or am I finding a critical value that's a t coming from a t distribution? Again, to decide which curve you are pulling your critical values from, it has everything to do with the standard deviation. In this case, because we've decided we were only given the sample standard deviation S, that means that we need to use a t distribution curve. So let's head over to Rguroo. In order to calculate critical values, we are going to come to the probability simulation calculator, and we are going to drop down and get our continuous probability calculator pulled up. This time we want to find a value. So we need the mode of the calculator to be pointing to critical value. We have decided we are not using a standard normal curve because we were not given the population standard deviation. So we are going to select a student T curve. Now this T distribution, as I described in the overall lecture of 10.2, is a family of curves. It has one center, but it has many different standard deviations. So you'll notice these three boxes to the right are pre-filled in as a default. You'll never have to change those. However, the degrees of freedom is what tells the calculator which of the T curves do you need to use depending on your sample size. So degrees of freedom, DF, that's a very small formula of just sample size -1. So we look back and we see our sample size was 27, making our degrees of freedom 26. Now, when we are talking about confidence intervals, that confidence level is always, always, always a centered middle area. So we will always be selecting between. Recall that in order to calculate a between problem, we actually need to find out what the remaining area is in each of the tails. So let's pull up our calculator so that we can do those calculations. So what we do know is we are doing a 90% confidence level, and that implies the 90% is an area centered in the middle. So we take our total area under the curve. Do you guys remember what that is? One, good. One whole probability distribution or 100%. Subtract what we know is in the middle of the curve, and we see that we have 10% or 0.1 that is left over for both tails. Okay, remember that's the total leftover that's not in the middle. So you're going to want to take that total and you're going to want to divide that by 2 tails. 2 symmetrically distributed tails, which means exactly half of the remaining area is in the left tail and exactly half is in the right tail. So we have, here we go, 5% of the area in the left and 5% in the right. So coming back to my probability calculator, I will paste in 5% in that lower tail, 5% in that upper tail. And when I hit my eyeball, notice that these are a positive and negative number. They are the same number. Again, this is because we have symmetrical curves, whether we're working in the standard normal or one of the T distributions. So when we're finding critical values, they're always going to be the same values, but different numbers when we're doing between or confidence interval problems. So you only need one of these numbers to enter into Hawks. Let's see how many decimal places. It wants 3 decimal places. So that's 1.706. Yay! And that's us finding a critical value. All right, let's take a look at a problem that gives us a data set because it's been a little while since we've entered a data set in. Let's see, here we go. So we have noise levels at 6 airports. Ooh, sample size of just 6. That is very small. So we will need to be told that our data is normally distributed or this will not pass the central limit theorem. And then we are given the quantitative data set of those 6 data values. We want to construct a 90% confidence level. My goodness, every problem I'm doing today is 90%. That is not always the case. And we want to assume the population is normally distributed. Thank goodness, that just passed our central limit theorem. So we're good to go with this small data set. Now it wants us to calculate the sample mean. So calculating a sample mean from a small data set You may be comfortable just doing that out by hand, but it's going to save you a lot of time if you just put it in Rguroo. We're going to need the data set for the rest of the steps of the problem anyway. So let's review how to put a data set into the data set editor in Rguroo to get that sample mean. So first, let me copy down this data set so I don't have to click back and forth. That's always difficult when copying. Okay, I'm going to head back over here to this very first tab that was open when I first signed into Rguroo, my data set editor. If that tab is no longer open for you, remember you can get it by going to Data, Data Import, and creating a new data set. Okay, so that's how you can get this data set editor back open if you had closed it out in the beginning. All right, we only have one variable with 6 data values, so let's get those typed in. So we would type in, well, you know what? I probably could have copied and pasted the data. Is that an option? It is. I could have copied and pasted it, but I already wrote it down. I forgot I could do that. So let me just type these in. I already got started. 54, 153, and 130. All right, let's save our data set. I'm going to save this as 10.2 practice example and save as. Okay, because it said it wanted a sample mean, remember we do have a summary button up here that works for sample calculations. We just got to be careful to remember that if we ever do need population calculations, that we need to go to analytics and the numerical summaries calculator. But because everything in this data set is a sample, I'm going to hit this little summary button. Scroll over until I find the mean. I see the mean is 145.666666. So 145.67. I don't remember how many decimal places it wanted. Let's go back. 1 decimal place. So we have 145.7. All right, let's move on to step number 2 of this problem. So step number 2 says calculate the sample standard deviation, S. Okay, again, we are not given the population standard deviation in this problem. So when we get to the confidence interval, we will be using a t-distribution for anything critical value or confidence interval itself. So because it's the sample standard deviation, that is the one that's calculated in this summary button. If we needed population, if we were told we were given a population, which is not what we have, we would need to go to a different area to calculate that. So here's my standard deviation. How many decimal places did it want? 1. So we have 14.7. Okay, so let's type that in, 14.7. All right, step 3 of this problem asks us to find the critical value for the 90%. Okay, again, before you jump to the continuous probability calculator, you do want to remind yourself, 1, we're finding a value, so I need to make sure the mode is proper at the top of the calculator. And 2, do I need a standard normal distribution or a z distribution? Or do I need a t distribution? We are not given the population standard deviation in this problem. We could only calculate a sample standard deviation from the sample data given. Therefore, we will be selecting a t-distribution. So I'm going to close out this summary screen. I'm going to head back to my probability calculator. Again, I'm going to make sure the mode is proper. I need a critical value, so the arrow needs to be pointing to value. I am using a student T. Degrees of freedom always stands for this sample size -1. In this case, my sample size was 6, so my degrees of freedom would be 5. And we already calculated what the area are in each tail for a 90% confidence interval because the confidence level from the last problem to this one didn't actually change. So we don't get to practice that again, unfortunately, for this problem, but let's hit our eyeball. And my critical value is 2.015. 3 decimal places, so 2.015. So z-scores are typically rounded to 2 decimal places. T values are always rounded to 3. Why they're different, I have no idea. Excellent. Last up, step 4 of this problem is to actually calculate that 90% confidence interval. We will be using the data set that we created to do that. So coming back to my tab that says mean inference, in order to open up the calculator again, I'm going to hit my basics button. This time I'm going to select the data set that I want, 10.2 practice example. Notice that everything cleared out and these boxes are grayed out because now they're going to be calculated based on the data the moment I select a variable. I didn't label my variable. There's only one variable in there, 6 data values. And it automatically says, hey, I recognize this as a sample, and it calculates sample mean, sample standard deviation, and our sample size for us. Also, when we're using a data set and we've selected var1, notice that the label here is already pre-filled for us. I'm going to change the default of 95% to 90. And because I only have a sample standard deviation, I am going to be selecting a t-distribution to calculate this confidence interval. I click my eyeball and I can see that my lower limit is 133.6 when rounded to 1 decimal place. And my upper limit is 157.7. That completes that 4-step problem. All right, there's one more type of problem that I wanted to bring to your attention, but before we do that, I want to head over to the book so I can show you the formula, because the last type of problem in 10.2 that you will be using is a minimum sample size problem. And this particular problem is not a preformed calculator in our Rguroo. We do actually have to calculate out the data itself, the formula itself. So if you come over here to the Learn mode, which is our e-text, and you click on page 13, our formula for means, and it will be a different formula for proportions, your minimum sample size, and what we're really trying to find out here is I am trying to make sure that I do an experiment where my margin of error, this big E variable, my margin of error is within a certain percentage. I don't want it to be crazy big because then my data is not very accurate. I want it to be within a certain amount. And in order to make a specific situation happen, this formula is saying, well, how many people do you need to survey to do that? Okay, this is funky looking Z is our critical value for minimum sample size problems. You do always assume to use a standard normal curve. We don't distinguish between Z's and T's in these formulas. We'll use whatever standard deviation they give us, and our margin of error is usually written with words like no more than, does not exceed, and then an amount talks about after that, or within are those key words to look for. All right, given that formula, let's head back to the practice mode and let me find a problem that asks for us to find a minimum sample size, and we'll practice that together one time. That's a critical value problem. Here we go. A market surveyor wishes to know how many energy drinks teenagers drink each week. They want to construct a 95% confidence interval, okay? And they want the error of no more than 0.09. So that's your key words. Remember that big E that I said was margin of error in the formula in the denominator? That is that reference, error no more than. It might say error does not exceed. It might say errors within. Okay, but that's your key words, that this is the margin of error. Typically, the words margin of error is not explicitly written in these problems. A consultant has informed them that a previous study found the mean to be 4.1, okay? And we have a standard deviation of 0.07. Again, it is not critical to recognize whether the mean and the standard deviation are population or sample, because this minimum sample size problem assumes sigma and assumes a Z distribution. Now it's asking, what is the minimum sample size? So again, the question really gives you the hint to what formula or what distribution you're using. In this case, it tells you what formula, the N equals formula, and we need to figure out what that is. All right, so let's head over to our Rguroo. We're going to just pull up our scientific calculator because, again, we need to just use the formula as is. That formula has a fraction raised to a square, so I'm actually going to set up the formula first with a fraction inside of these parentheses and it all being squared, so I don't have to worry about remembering to do that after. We have read and identified that our margin of error was 0.09 because it said it wanted the error to not be more than 0.09. In this numerator, I need the critical value, and then I need to multiply that critical value by the standard deviation that was given of 0.7. The only thing I don't have right now is the critical value, but remember we can find that by using our probability calculator. So I'm going to head over here. This is the first time I'm showing you how to find a critical value for a Z distribution. The last couple problems had us using a T. So again, make sure your mode is pointing to values because we're finding a critical value. And we want to select the normal distribution. For a critical value, it is always a z-score, so you will not be changing the mean and standard deviation because we need that to be the standardized mean and standard deviation for the standard normal curve. But we do need to calculate what is the area in either tail when the middle this time is 95%. So we do get to practice. Let's head back over here. I can actually use my preformed formulas here. The total area under the curve this time minus 0.95 leaves me 5% left. I'll change my numerator to 0.05. Dividing that total area that's in the two tails by 2 tells me that 2.5 or 0.025 is the area in the left and the right. So I copied that. I'm going to head back over here and paste that into my lower tail. Apparently I didn't hit copy. There we go. When I hit my eyeball, I see the critical value is 1.96. Remember, you don't need both. You only need the positive one for this formula. So I am going to finish up my formula by putting in the critical value for a 95% confidence interval of 1.96. And I see that my minimum sample size is 232.39. Now, the rules for rounding for minimum sample size problems is you always round up. Because you need 0.4 of a person here, that means that you need to make that minimum threshold of 0.4 of a person. So the only way to get that minimum threshold is to round up to the next person. So we will enter a minimum sample size of 233. Yay! All right. Hopefully this video helps you get through that 10.2 homework. Thank you.